This area here is, after it goes through that divider, which is the head pressure, brings it here, comes down this channel, and from this channel it comes into here where grit is removed. It would be nice to do this before we hit those raw pumps, but it just wasn't feasible with that elevation. So we are looking at making changes with that. What happens here is we add a lot of air. The air allows solids to drop out. And then on the other side over here, there's another large weir. That is where it overflows. And then that goes off to the oxidation ditches. The grit material is picked up by a conveyor and is picked up and run into this building here. And then that is where it's picked up and put into another dumpster. The rest of this building on the other side over here, which is what you may be able to hear the blowers. I don't want to get into it. You wouldn't be able to hear anything if I walked in there. You need ear protection. But these blowers here are for our digesters, and we'll come back to that area here in just a little bit. They also have they bring air across also as well over here for this to be able to make the grit work. This next little box here is a splitter box, and it brings or separates into different channels. So we take it from here, and then we can take it on down and feed all of our ditches. And you can see out here we have a sampler, so we get an idea of what is going on out here. And you can see right now we've got the rotors working on this one. It's a really good dark color. This is, and you can see a little bit of foam that comes off, but you don't see excessive foam. So you don't see a lot of scum floating around. You don't see a lot of foam material. So there's a good balance of food, oxygen, and bugs. And that's what we grow here, are bugs. And the bugs gobble up all the solids, which is the fecal matter and byproducts, the waste products that people send to us. This is a very, very efficient means of treating it. You can just see how concentrated it really is in here. I think we're right around 3,700 in here in the ditch right now is what we're running. We have to run a little bit higher than what we'd probably like to, and the reason is that we have copper residuals that we have to try to get rid of, and so we need a higher concentration of bugs to be able to get rid of that. We have a shallow ditch over here. This is kind of what it looks like without anything in it. And the reason that we're not operating this one right now is because we do not have enough food to warrant it. And that's what we base everything on is that food. And that food, again, is the bug population or that concentration that we would see of BOD. So, which is that biological oxygen demand. So that tells us how high we leave the water, how much the rotors impact, so what DO we keep in here. And we try to keep right around 3 to 4, and that's a little high too, but it is better to be a little bit high here. It's been working very, very well. So we'll go from here to where it outfalls. And there's weirs in between these rotors. The outfall comes across and comes over here to this configuration, which is our clarifiers. We have a splitter box here, which is what picks it up and divides it between the ditches. And then we bring it into here, and it comes in the very center of the clarifier. And you see how that chocolate color is there in the center. And as it gets to the outside, it gets lighter and lighter. So what's happening is the solids that come out of the center then drop down to the bottom, and it's picked up by pumps that have a suction, just like this mechanism here kind of pulls the scum material that gets caught across the top and pulls it over and then catches it into what is a scum trap. Then the outfall is this area here, which comes over these weirs here, and you can see at this point it's relatively very, very clear. And you see that we got a barrier to catch all that and protect the outfall from any of the scum trappings that float on the top. So what comes up is what's about 6 inches underneath, which is really good. And we usually keep roughly about 2 feet or so of solids at the bottom. And we keep these pumps running all the time. They're down underneath here, which is where all this kind of gets collected, comes in. We've got samplers again here, and again we pick this stuff up here, and we either return it back to the ditches, or we waste it back to digestion. Or this clear water, and I should say not or, all the clear water, which comes back and then goes back over here to our chlorine contact. As you can see, there's some algae that gets developed in here. We try to keep a handle on that. That's why we have brushes on here, and we have to add some chlorine bleach to clean off the edges, and we keep brushes going in here to keep this thing from developing too much. You can see this arm here is not turning. I'll have to talk to the guys and see why. There's she going. Okay. This tank here is our EQ basin that I was telling you about, and you can see that it's only used when we have high flows. It's fairly shallow. The inflow is that pipe that is over on the left side of that weir area, because that's what it is. There's another pipe at the bottom, and then it fills up, and as it fills up into this tank, then it has a weir that it overflows in. So again, this wall acts as a separator for anything that's trapped on the top, and holds that in, and then it flows over, and then through a measuring device, back and around, and then back into the chlorine contact tank. Chlorine contact tank is that round tank, and the SO2 tank is this. We use SO2 to remove the chlorine. We use chlorine to kill any kind of bacteria or bugs. Again, here is that basically that weir for the overflow. Once it gets below this point, anything that's trapped here will go back to the headworks. We then clean this down and wash it out, and we're ready again to go again. So that's a good thing. We also add oxygen here just before it flows over the weir, which is another measuring device again. That's what weirs are measuring devices. So we keep oxygen in the water and try to keep it roughly right around 6 parts per million for discharge and out. And in this, it goes from here and then out to the creek, out through this manhole structure here. And we have another measuring device in there. Coming back over here, this is the chlorine. Comes back through here. We can send it here, and we can send it into this building here, which is our filters. So we have tertiary filters, which are anthracite, to be able to handle the water as we need to. You see, chlorine is fed clear back over there, which gives it a lot of contact time. And that's what we try to do, is just make sure that there's plenty of time for it to work. That way we don't have to use a lot of poundage. And that's what we try to do, is maintain so that we aren't wasting our chlorine. And then the SO2 is fed at the beginning of this, which is where that equipment is there. And that's where we start to remove that chlorine. And then the air, and then out. The solids that we collected back at that clarifier go back to this building. This is where we take the material and thicken it. It's digested, and that's why they call them digesters. So, with